do that easily. Yeah, I can do that easily. Okay, so yeah, that's recording. All right, so did you tell me where the confusion starts? Did you try it, or where's the, you want to walk me? Let me just share my screen as well, and then I can
Yeah,
walk you
sure.
through a calculation.
Let me think of like the best way to like kind of explain this. Okay, so I remember like hearing in class like that, yeah, you had that like slide pulled up, and
Right.
then it was like multiply the rating by number of hours in the year,
Right.
and that like it's supposed to tell you like how much wind power a wind turbine could produce. So you have
Right.
that rating times the number of years, and I calculated that to be like the 1.5 MW, and then times how many years, 8,750.
Right.
And then I got equals 13,125.
Okay.
And then and my formula I wrote down like, oh, like then times by the capacity factor. Is
Right.
that right?
Yeah.
So I did 3,938.
So you multiplied that 13,000 by the capacity factor, which was 30%, right?
Yeah, I don't think I did the 30%.
Okay. Because that's where you'll go wrong, Madeline, because I'm going to change the numbers around. So here's what it looks like. So if I give you a wind turbine that has a power capacity of 1.5 megawatts, right? That's how much power the wind turbine can supply if it's operating 24/7 times 365 days, right? Does that make sense?
Okay.
Right. So how many hours are there in a year? Well, there's 8,000, what did we say it was? 8,760. So there's 8,760 hours in 1 year, right?
Yes.
So if that wind turbine is turning and generating the power right at its maximum power capacity, then it's 1.5 times 8,760. That gives you the 13,000, whatever the exact number is, 13,000, I can't remember. Yes, I can do it. 13,200 or whatever it was, right? That's the total number of megawatt hours of energy that is generated by that wind turbine spinning every hour of the day for a year. Yep.
Okay.
Make sense?
Yes, I just yeah, I think I just was like trying to do like a formula, and I had written down like, oh, it's the MW rating times the number of years. So we have the 1.5.
Number of hours.
What was that?
You said the number of years. It's the number of hours, right? So
Oh
that's
yeah,
what
hours in a year.
That's what we've got here, the rating times the number of hours. Then you're going to multiply that by the capacity factor. I've got to give you the capacity factor. Right?
Okay.
Let's say I give you a capacity factor of 10%. In other words, this wind turbine is not generating its full 13,200. It's only going to generate 10% of that, right?
Yeah.
So you multiply 13,200 by 10%, and that gives you 1,320 megawatt hours of energy actually generated, right? Not the 13,000, because only 10% of 13,000 is generated. So it ends up 1,320, right? And then the final part of that is you just take that and you divide that. So if a wind turbine is generating 1,320 megawatt hours, divide that by how much energy is consumed by the average home. If I say to you, a home on average consumes 10 megawatt hours per year, right? Then how many houses can that wind turbine support? 1,320 divided by 10 is 132 houses.
Let's see. Okay, I just, yeah, so you're saying like once you get times the capacity factor, then you get 132, and then you said divide it by how many how much the household consume,
Yep.
and that would be 10.
Yeah. It could be anything. I'm going to give you different numbers. That's why I don't want you to memorize the numbers, because I'm going to give you different numbers. I need you to understand how to do it.
Do you think we could do like another like problem with different numbers just to make sure I can do it on my own?
Yeah. So let me just pull up a spreadsheet here, and I'll plug in a couple of numbers here. I'll give you an example. Yeah, let's see. Let me come up with a different example. Okay, so write this down. Let's say you've got a 1.5 megawatt wind turbine, right?
Yes.
Operating at a capacity factor of 25%. Yep.
Yes.
Let's say the average American household consumes 6.5 megawatt hours of energy per year. How many houses can that wind turbine support?
Okay, so you have to do the rating, which is the 1.5 watts. Wait. And then here, should I like share my screen?
Yeah, hang on a second. Let me just unshare mine for a second. I need to. My computer's very slow this morning, and then I just quickly need to allow you to do it. Okay, so go ahead and share your screen.
Okay. Yeah, I'm on my Mac right now. I don't know if PowerPoint would work.
Yeah, should do. Do you have?
I always like do PowerPoint on the PC. So I don't know, like I guess I could always just do like regular Google Docs and type on there.
Is it working?
Yeah, I'm going to share my screen.
Okay, cool. There you go.
Yes, I have the 1.5 and then times the number of hours in a year. Was that the 6.5?
No, there's not 6.5 hours in the year, Madeline. How many hours are in the year?
Oh, okay. Yeah. So
it's the 8,760.
Did you like when you gave me the example? I don't remember like hearing that, and I didn't write it down.
Yeah, that's it. So you take the power rating times the number of hours in the year, like 8,000. So just take that. That's going to be standard. That 8,000.
Okay. Good to know. Standard.
Okay.
Okay, and then equals. This is like gonna tell me how much the wind turbine produces. So 8,760 times 1.5 is 13,140. And then the next step is to times it by the capacity factor.
Yep.
And that's the 1%, so 0.25.
Correct.
3,285.
There you go.
And okay. And then the last part is to divide it by the consumption of the household, which that one would be the 6.5.
Mm-hmm. And that gives you what?
505 and then 3.
So that one wind turbine operating at a 25% capacity factor with a household demand of 6.5 megawatt hours per year can support about 505 houses. That's how it works.
Good. Yep. Yeah, I think I was just, yeah, I definitely I forgot to do the percentage part. And then I'll definitely make sure to remember that 8,760 is the standard amount of hours in a year.
Cool. So that's good. What else on the renewables can I help you with?
Well, I definitely think an important thing to remember is that Texas is a state with the most wind power. Mm-hmm. And then you have China, the country,
Mhm.
the most like wind power energy.
Yep. 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 Yep.
And then yeah, definitely like going off the study guide, like I got it, you know, like the important wind aspects of wind, solar, and hydroelectric, like you know, the pros and cons of each.
Right. Yep.
And then yeah, definitely the difference between like power energy and the significant capacity factor.
So that's going to be that'll be asked in the calculation question.
Okay, because yeah, because capacity factor, that was the one with the percentage.
Right.
Okay.
Right.
Good to know.
Yeah. That sounds good.
So I was just like kind of thinking about like how can I have like good time management on the exam, because the last exam I actually like felt like I finished too soon. I had a lot of time left over on the last couple problems and I wasn't able to go back. Well, the
Yeah.
test is similar where you're not able to go back.
Yeah, unfortunately it is. I just had such an issue last year with students going back and then spending 5 minutes reading through their book and doing that. So the written questions come at the end, and so I would say you need to be done with your multiple choice by 30 to 35 minutes, somewhere in there. And by then there's only 25 or so questions on the multiple choice. So
okay, good.
you should be able to get through that pretty comfortably.
Okay, yeah, 'cause that's important to definitely like.
Yeah, and the
Even if-
calculations and the written ones, they come at the end. Yeah.
Yeah, I definitely don't want to spend too much time on the multiple choice and then not have enough time for the last
Right.
part and leave some blank. You don't want to leave some blank like the last test.
No, blank doesn't work. Blank doesn't work. So yeah. So just budget your time on that.
And then am I able to have like a sheet that with the wind turbine formula written down that I can use?
Well, I mean, I can't police that. Technically, no, but I can't police that, you know. So yeah, I don't believe in sort of lockdown browsers and flying drones over people's heads and things like that. Yeah.
And
Yep.
yeah, I think that's like yeah, like pretty good. I feel like a lot better about the renewables now that
Yeah, renewables should be more straightforward for sure.
yeah, I just think I definitely need to work on air pollution.
Okay.
So yeah, because I don't have any more questions for you, but I feel like after looking over air pollution, I might have some more. So do you have any time like Sunday or Monday to meet a little
Good
bit?
times. Just send me some times that will work for you and I'll slot you in.
Thank you so much. Have a good day.
Thanks, you too. Bye.
Bye.